Hello, and welcome to session on vulnerable coastal ecosystems. And we have a pretty diverse set of ecosystems from around the world that we're going to be talking about. So we're going to have 4 presentations, and then hopefully we'll get to sit up here and discuss and have questions. So
And we have some people on Zoom. Do you want to speak into a
okay, Mike.
Hello.
Okay, and so we're going to start off on cultivating islands, a case study in the Maldivian atoll by Despina Linaraki.
Thank you so much. Hello. So my name.
Try the mic on the table. So sorry.
Yeah,
Okay.
This one. Hello.
Oh, try it.
Hello. Yeah. Okay. So my name is Dr. Despina Linaraki, and the presentation I will have today is part of my PhD that I started in 2019 and I submitted in 2024. So it's a really big project that I will show you in 15 minutes, or I will try at least. Therefore, I'm pretty sure you're going to have many question marks that we can discuss eventually later on. So I will start with the part 1, which is cultivating islands, the idea of cultivating islands. And I want to start with this image, which was back in 2009 by the former president of the Maldives, where they held a cabinet meeting underwater to emphasize the threat of sea level rise in the coral islands. Like most of the low-lying areas and islands, the coral islands are facing a lot of threats by sea level rise, but especially because the coral islands are very small islands that they are only 2 to maximum 3 meters above water. So this research is focusing specifically only on the islands that have been made out of corals. It's focusing only on these little islands. I don't know if you have ever been or if you have an experience of the coral islands, but they are magnificent places in the world. So the Maldives is a complex of pure coral islands, and that's why this research is focusing there. At the beginning of my studies, I wanted to focus on the Pacific Islands, but because of COVID, there wasn't much data available online. Therefore, I moved to the Maldives, that the data was more accessible, of course, because of the all the resorts and the development that is happening. Okay. So when we discuss about managed retreat, it is a very important adaptation method, especially at the final stages where you don't have any other option, you don't have any other adaptation strategy. But it is important to understand what does managed retreat means for these islands, for these people. So there is this feeling and idea of islandness, which refers to the connection of the people to their land and the water. So this idea that the smaller and the more isolated the island is, the stronger the connection to the land, the water, and the culture is. So there are different policies that have been developed throughout the world, especially on the coral islands, about managed retreat or retreat with dignity, that I think Kiribati is doing now in the Pacific Islands, where they try to give to fund the younger generation to study in order to be able to go and work in more developed countries. Or they buy land at Fiji and they are planning to relocate to Fiji or in Australia. But people don't want to relocate. They don't want to leave their country. And that's the same with the Maldives. When I went there, I discussed with the locals. I had tried to have many discussions. People don't want to leave. They want to migrate to the capital in Male because they have more opportunities for residential opportunities, for hospitals, for the universities there. So they want to migrate, but they want to know that they will be able to go back to their land. So if there is available land in this particular country, then people, yes, of course, they can move inland of, for example, in Hawaii, that I was before in the session where there is a managed retreat happening in higher areas. However, for the Coral Islands, there are no such areas. So where do these people go? And of course, I'm an architect in the background. I'm trained as an architect engineer, and my focus is on how do we use this adaptation strategy of advance? How do we expand in the water? So I went across and I studied all the artificial and natural island growth processes of islands, and I came across this fascinating study that shows that the coral islands are actually dynamic landscapes in the water, that they change continuously. There is continuous erosion, but there is accretion happening as well. And that's because the coral islands are made by these tiny fragments of dead corals. So this is a sectional diagram of sorry, pointing? No. Okay. This is a sectional diagram of a coral reef ecosystem. And as we can see at the edge here, we can see the reef crest and then going into the reef flat. So the corals are mostly growing in this location here. And that means that the corals grow there because it's a high energy environment. So they need the nutrients in order to grow. And as they grow stronger, they grow the coral reef that is acting also as a wave breaker. So these are multifunctional dynamic systems that they grow at the edge of the island, they protect the island, but at the same time they grow the sediments in order to grow the islands in the middle. So the waves are breaking the corals and the currents are transferring the coral fragments in particular locations. Not all the coral reefs have islands, but when the land is suitable, then little islands can be formed. Of course, this is a process that takes decades, but at the same time, if we have an extreme event like a cyclone, we have seen the formation of land masses happening within this cyclone period. Okay. So how can we grow islands in these dynamic environments? This is a combination of interest of different stakeholders, of the corals, of the environment, and of the people. So when currently what we see the trend is, especially at the coral islands, that we go there. There is, of course, an environmental assessment report happening always to see what is happening underground. But because of the need and the necessity, the trend is that you usually build the whole coral reef. You build an artificial island on top of the coral reef. And then there are reports and there is research evidence saying that when you destroy or you build on top of the reef, or when you don't allow the reef to grow, then immediately you destroy one of the most important natural protection elements of the islands, which are the coral reefs. So we need to allow them space to grow, and we need to allow the sediments to be able to move in order to create erosion and accretion. And we need to have different zonings. So throughout the PhD, I tried to develop a framework about how can we grow islands in coral reef environments. So how do we gather the information to identify the different forces and then to set priorities between these three different systems, the environment, the corals, and the human. And then how you use these systems in order to propose form, refine the form, and then evaluate with the community and of course with smaller scale projects. this framework is being divided into secondary and more categories that I will not show you now. And then I will just show you very quickly a case study in one of the Maldivian atolls. So the first part, which was the information gathering in order to identify the forces and set the priorities of how do we build islands or build land in the water. So in the site analysis here, we are not only identifying the geomorphological analysis, but we should also do a benthing analysis and an environmental analysis and a climate analysis and put all the forces and the parameters together. We need to understand how the islands were developed, what is the natural development of the island, in order to help enhance these natural growth processes. And at the same time, we have a design brief, we have the needs of the community and of the people about the land expansion. So there are many different parameters that they come together to define these priorities. So the atoll, the reef actually that we decided to use for this case study is this one here. So with the red dot, you can see Male is the capital of the Maldives, approximately in the center of the Maldivian atoll. So this reef was very close to Male, and it is a natural reef. Back then, when we decided to have this reef, there were no artificial islands there, and it was a very interesting geomorphological shape. That's why we decided to have this. However, currently, this reef has started a journey of becoming a full artificial island because of the new government of the Maldives, that they are actually building the whole reef into an artificial island with land reclamation. So the first step was to understand the historical growth analysis, because as I said, these are pure coral islands. So what are the specific coral species that they helped in order to grow this island? The geomorphological analysis, there is a very important research happening by the Allen Coral Atlas that I don't know if you're aware of. They do a lot of analysis in the geomorphology of the coral reefs. And it is a very useful tool actually for architects or engineers who want to build in the water. And this is very interesting because you can see the scale comparison of this atoll with Manhattan. So you can understand if this atoll was to build fully, then it would provide a lot of residential spaces for the people. And then benthic analysis, understand the living organisms that are growing there. This atoll has been through cyclones. So there were only 2 species growing there, and these are the species that we proposed to grow further. Understanding how long the growth rate, how long they take in order to grow, and what can they provide as ecosystem services in the proposal. And then understanding also the environment, where the currents are coming from, when the predominant winds, the predominant waves are coming from, and how the sediments are being transported from one side to the other. And as we can see here, there is a big deep lagoon in the middle. So even though you have the waves and the currents moving from the west to the east, there is a big lagoon that is actually receiving most of the sediment. So we don't have any natural islands forming there, just a sandbar at the top. And then, of course, the design brief. So as I said, understanding the needs of the people and what can we fit there. And there are 3 different islands that back then I went and I had a community meeting with the Maldives trying to understand, okay, what's the size they prefer? Maybe more dense islands like the Male, the capital, or less dense islands like Male, a new artificial island they have, or like the traditional islands, Gili. So you can see also here the same amount of hectares in these different configurations and how many islands we could fit in this reef. And then, of course, understanding this is a sectional diagram of the reef where we have overlapped different maps, the geomorphological map and the benthing map, trying to understand what living organisms are growing there and what can you build where. How can you use what exists already, the environment and the living organisms, in order to propose what architectural design you are going to do? So for example, in the deep lagoon, probably some floating structures in order to have coral reef, coral nurseries will be really beneficial. Or here, build nothing, of course, because it's the zone that the corals are growing. So there is a zone that you need to keep intact. But you can grow wave breakers. You can grow also habitats for corals in order to grow more and provide sediments or protect the region. So then we set up the priorities, and different priorities are leading to different projects and different design methodologies. So for example, if the priority first is enhance the natural growth processes, the second priority could be expedite the island growth, and the third, adapt to sea level changes. These three priorities came up because they are always contradicting in between the different stakeholders. So always when we discuss about, okay, building artificial islands, these are the things that come up a lot, with the most common one, expedite the island growth. And that is what we usually get as an argument back from this research, that the corals, they require a lot of time to grow. So that's when the second part of the framework comes in place in order to use all these different parameters that we have defined, and I'm not showing here right now, but actually the whole idea is how you overlap these different maps where you have the living organism, the geomorphology, and then you have also the needs of the artificial structures and the needs of the people in order to start developing. So here we are just showing how can we place in strategic ways some curved walls in order to enhance this, the sediment growth and movement, but also to enhance, to promote the coral attachment and growth in this particular location. And then we go one step further, trying to show, okay, how these walls could have been developed in order to cultivate corals and grow the sediments eventually, and where they need to be placed, and the scale of the island that we can grow. Or the second one, if we want to expedite the island growth, then structures raised on stilts is something that is very common. The knowledge is very common. So placing stilts in strategic locations that they have the bio-enhancing surfaces in order to attract corals and grow the corals in these locations. So not only provide habitats for people, but provide habitats for corals at the same time. And how can these work together? And then floating structures, where can you create floating slabs where corals can grow now, and then eventually in the future, they can be used as slabs for floating housing. Or even a combination of all, and how you need to respect the smaller scale and how you need to respect the environment, but allow the environment to allow the sediments to move, allow them, the corals to grow, even emphasize this process. So these are two of the articles that we have, but the whole research has been published now. It's my thesis, and you can find it online. And then we did a workshop in the Maldives because we wanted to discuss with the people how important, for example, they think that it is to have a framework that incorporates corals on underwater structures. Because currently we've seen that there are different frameworks for different stakeholders. So there are the environmentalists, there are the engineers, that they have different interests, but there is nothing that combines everything together. And then the very important thing is that community engagement is the most important thing. I would just say that, and I'm finishing. Community engagement is very important. So if the community is not willing to grow and maintain these structures, then of course this research will never be succeeded. So it's very important to know that the people want to do that. And of course, the challenge for this proposal is the time frame, and that the different framework involves different stakeholders. And I would just like to thank the people of the Maldives who allow me to do this research on their land, and all the people who helped me with this research. Thank you. Hopefully I didn't go a lot of the time.
One quick question, the next one.
Yeah, wow, that's super interesting. I'm glad that I am in this talk. That's great. How do you consider different environmental kind of detriments like ocean acidification, temperature, and possibly toxins affecting your?
Yeah, I mean, there is a lot of research happening now about the corals. So because I am in Australia, I'm working in Australia at the very close to Great Barrier Reef with a lot of scientists who are working on how will the corals survive. So there's a lot of research happening on how the corals will survive in the future. They add them nutrients, now they add them vitamins to try to help them. But also it's the species that you will select for the structure. So after the cyclones is a common method that you select the species that they have survived, or after a big bleaching survives, so you select the species and they try to enhance this species growth more than the other. But there is, I mean, of course, change, but there is a lot of research happening right now that it gives a lot of hope for the future and survival of the corals, which is actually amazing. And at the same time, I'm just trying to do my part from the architecture point of view. So instead of just putting things in the water, what can we do in order to emphasize the growth of this?
Hi. You have a question?
Yes, but I'm not sure if there's time. Just a quick
Yeah,
one.
sorry, just speaking to the mic so people on Zoom can hear you.
Yeah, sure. Yeah, thanks very much for the very nice presentation. Just very quickly, my question is whether the coral reefs can survive the building, basically. So I think the main stress for the coral reefs will be the building works for developing the region.
I'm not.
So sorry. Can you answer to the mic so people on Zoom can hear? Thank you.
Thank you so much. There needs to be a zoning, because the coral reefs, they need to be protected. We can't build on top of the coral reefs or in areas where they might grow. However, because we build nevertheless in the water, what I am saying and what I'm trying to propose to the government is, when you build something in the water, create a habitat for the corals as well. This is going to have benefits for the environment, but also for the future and the people. Thank you.
Okay, thank you. And now we're going to move on a little closer to home. So community visioning and land restoration in New York City by Veronica Olivotto.
Hi all. I'm here to present research I undertook during my PhD at the New School at the Urban Systems Lab. This work is indebted to the Edgemere residents and community-based organizations that welcomed me in their neighborhood and entrusted me with their stories and experiences. These pictures show 9 vacant or derelict lots in Edgemere and Rockaway in the peninsula of Queens. 10 years after Superstorm Sandy hit this peninsula with catastrophic consequences. 7 lots are acquisitions and buyouts, and 2 lots were previously vacant. Some are fenced, some are encroached upon, some are mowed, others are not. Post-disaster landscapes that go through managed retreat and have a history of disinvestment are particularly difficult to inhabit, both physically and emotionally. Buyouts and disinvestment have one thing in common: they leave vacant land behind. Indeed, we know that buyouts often occur in neighborhoods of color that experienced white flight, and districts that have been redlined where properties are already depressed, and so they qualify more often for substantially damaged by FEMA. Because buyouts are reactive to a disaster, properties are acquired in a checkerboarding fashion, which we heard a lot in a panel I was in this morning, meaning that buyouts are interspersed with existing lots, leaving smaller vacant, lots behind. We know that checkerboarded landscapes can inhibit floodplain restoration and result in mixed ecological outcomes. Neglect or lack of site restoration can contribute to a sense of loss among buyout participants and discourage others from participating in buyouts in the future. Although targeted buyouts are suggested as a way to invest in underserved neighborhoods, buyout programs often fail to deliver on the promise of floodplain restoration due to costs and maintenance requirements. Post-buyout land restoration often fails to account for historical oppression of Black and Brown people and their place attachments. The neighborhood of Edgemere in Queens, where I conducted my research, is a predominantly Black and Brown neighborhood of approximately 8,800 people, where post-buyout lots, here represented in red, are surrounded by many other vacant lots in pink, making up 16% of the Edgemere land, compared to a New York City average of 8%. This is a result of failed city-sponsored urban renewal plans in the late 90s that were halted by the mortgage foreclosure crisis. The east side of the Rockaway Peninsula, where Edgemere is, experienced double the New York rate of foreclosures in 2011. While there are examples of participatory land visioning engaging residents in thinking about future open space use, both the experiences of land restoration and the process through which this is achieved is under-researched. So in my PhD, I asked to what extent, or at least parts of my PhD, to what extent can participatory community visioning after retreat help to inform land restoration options by and for the residents of the neighborhood of Edgemere? At the core, I think adaptation practices like retreat and land restoration reawaken all critical debates on the value of public participation and planning. By foregrounding procedures and processes of adaptation, we can better attend to the politics and stakes involved in community visioning for post-buyout land restoration. Following this understanding, I think a thicker and nuanced framework for procedural justice can emerge by bringing together different scholarly understandings of procedural justice. So I employ dialogue as the exploration of possible worlds that post-buyout land restoration may engender. It includes openness, or who is joining the community visioning in Edgemere, whether there are mechanisms in place to involve different groups in sharing their views, intensity of involvement, or how people were involved in the community visioning in Edgemere and the extent of co-production of goals, and the extent to which the community visioning was able to achieve meaningful debate, elevating contentious issues and grievances. I also employed implementation of procedure as the decision-making properties, such as legitimacy, trust, and accountability, and access to debate, which include location and resources to sustain an inclusive deliberative process. I also understood during my fieldwork that I needed to mobilize two more concepts. One comes from the literature on transformational governance, or orchestrating capacities, which is the ability to coordinate issues that involve multiple actors, and civic capacities, or the ability to organize around common community issues to address the kind of contentious community problems where repeated interactions among different ethnic and class backgrounds can increase suspicion and distrust. So between March 2021 and February 2022, I seconded the Community Visioning in Edgemere, a collaboration between one Rockaway-based CBO, community-based organization, and a New York-based collective of women planners to facilitate the emergence of ideas for Edgemere's vacant lots. The project received approximately $50,000 by a prominent US environmental conservation agency. Before the workshop, I conducted land surveys with the CBO staff and students. And during and after the workshop, I spent time meeting Edgemere residents. I also familiarized with Rockaway's history, urban development history, and post-superstorm standing plans for the neighborhood. For instance, the Resilient Edgemere Community Plan, which designated a hazard mitigation zone, placing deed restrictions on city-owned lots to maintain them as open space, and where only buyouts and acquisitions will be offered following a new storm. The Build It Back program, which used federal funds to target this area for acquisition and buyouts, as I mentioned, but also completed 109 elevations and rehabilitations. And it proposed the creation of a rapid repair home program and the construction of 1,200 new, mostly market rate residential units. And finally, laid the foundation for the creation of a community land trust to encourage permanently affordable housing and manage some of this vacant land, including the buyouts and acquisition lots. So, to dig a little bit into the findings. Findings show how the civic and governance landscape, specifically fragmented civic action and underdeveloped municipal orchestrating capacities, influence the implementation of procedures, and in turn dialogue. And I'll make a few examples of this. Municipal agencies in New York are not strategically aligned to support the formulation of shared, integrated, and long-term goals for vacant land restoration after retreat. Agencies were unable to orchestrate or coordinate the collection of relevant information requested by the visioning organizers about admissible vacant land uses and their compliance with regulations on post-buyout land in floodplains. On the one hand, inadequate knowledge increased the intensity of participants' involvement by not restricting the breadth of temporary uses they could think of, but on the other, it disempowered visioning organizers who only could work with information that no permanent buildings would be allowed. But would farmers market or fitness parks? This potentially raised participants' expectations and eroded trust in city agencies' willingness to work with the community of Edgemere. City agencies were reluctant to greenlight interim use of vacant lots because of lack of mandate over vacant lots and budget to implement any use, which stifled any resident-led action when the visioning process was over, effectively reenacting the neglect that residents have been exposed to for decades, which I will mention in a minute. In turn, this jeopardized the accountability and legitimacy of the visioning process because it couldn't galvanize community members to organize around the implementation of any interim use. Moreover, the vacuum left by municipal lack of long-term plan for Edgemere's land restoration opened the space for a federal not-for-profit actor to fund the land visioning workshop. Traditionally used to do restoration and conservation work in North America's rural areas, this not-for-profit is gradually expanding its reach in urban areas using what's called rapid adaptive management philosophy, which is based on a startup model. Basically, the nonprofit wanted to learn novel ideas about how community visioning for land restoration in urban areas is done, but instead of spending years planning how to do good restoration projects, they work with a few organizations with little investment and learn from what goes well and what doesn't, and then apply the learning to the next project, which is, I think, the last thing that a neighborhood like Edgemere needs. The visioning tried to limit checkerboarding by clustering buyout lots with existing vacant lots, creating larger swaths of open space. And here you can see the different clustering based on size. Participants were encouraged to think big. And after a SWOT analysis and brainstorm of ideas, desired land uses were grouped into 3 thematic areas: economic generators, recreation, and food. With economic generators, actions like food truck vendors, multi-use facilities, and micromobility coming to the top. But insufficient investment coupled with the future-oriented designerly compulsions of visioning didn't allow for the kind of deliberative space that could unpack residents' past grievances and connect them to present struggles for adequate services and economic opportunities that the choice of these 3 thematic areas so clearly highlight. Ultimately, vacant lots were approached in a way functional to achieve consensus on future use rather than through conveying their lived history, which required connecting the history of vacant land with on-the-ground storytelling to unearth collective memory as a history of exclusion, like Bashir put it. This history of exclusion is made of powerful experiential feelings of recognitional justice, which were only brought to light during in-depth interviews I conducted after the workshops. I'll make a few examples. For instance, failed urban renewal translated in housing and services and in less housing and services and generated feelings of betrayal. Many homeowners like Lorraine, who bought their homes in the early 2000s after the Edgemere Renewal Plan was established in the late 90s, felt the process was a bait and switch because homes were built where there was no supportive infrastructure for the homeowner, no new schools, no recreation centers, no shops, even though this was what was promised to them. Another example is segregation and housing structural racism can generate feelings of group disrespect and neighborhood divisions. Alvin, who is the son of a neighborhood landlord, refers to the perception that some landlords abuse CityFEPs, which are city housing voucher programs, with the effect of creating a neighborhood with high renter turnover. Indeed, there's widespread landlord discrimination against families with vouchers who generally reject the program, especially in neighborhoods that are better off in terms of schools, jobs, and transportation, therefore limiting housing opportunities in better off neighborhoods and concentrating them in poorer areas like Edgemere. But this is nothing new. As a 2003 book by Kaplan and Kaplan recounts, for more than 2 decades, from the 1950s to the 80s, public housing developments were built in the Rockaways that eventually came to be occupied by welfare population. Rockaway residents frequently use the term dumping today also to describe the process by which New York City moved helpless, troubled individuals and family in its communities, where social services were notable for their absence. Edgemere present landscape is a product of racially motivated suburbanization, leading to a decline in housing condition that did not happen by chance, but is a result of little interest that politicians had in the land and people living on it, and where failed urban renewal befell through both local and cascading international market failures, such as the mortgage crisis. Which brings me to my last example. As a result of these neighborhood divisions, civic action in Edgemere is fragmented. There's little united and broad-based social and political engagement, which stifled the ability of visioning organizers to rely on existing coalitions with other grassroots organizations to increase the representation of Edgemere residents in the visioning process, especially renters who represent 80% of Edgemere's population. So although we had 115 attendees across the 3 workshops, 2 of which ended up being online because of the second winter wave of COVID-19, of the 35 attendees who answered a post-community visioning survey, 22 reported being from Edgemere, and the majority were homeowners. So very, very little renter participation. So some reflections here to conclude. I think relationships between dialogue, implementation of procedures, and broader contextual governance need to be impacted if procedural justice is to be seriously practiced in post-bio land restoration. To counter the effects of checkerboarding in post-bio neighborhoods, the City of New York should strategically choose lots as part of a long-term, proactively funded and incremental retreat plan that considers land use options from the onset, where all stakeholders understand what uses are allowed and are entrusted to maintain these lots as interim open spaces that serve communities for as long as they are in this neighborhood. Also, I think this research shows how the empirical existence of relationality between and vicious cycles between dimensions of justice, of which procedural justice is only one. Injustices of distribution can generate injustices of recognition, grounded in race-linked housing and planning policies. For instance, unmaintained promises of urban renewal can be linked to feelings of betrayal, while failures at dealing with concentrated poverty can be linked with group disrespect. Fragmented civic and weak social and political engagement in Edgemere itself is the result of segregation, stifled the ability of the visioning process to rely on existing coalitions with other grassroots organizations and increase and galvanize workshops attendance. As a result, many of Edgemere's residents I spoke to see retreat as another sign of neglect. Based on these relationalities, I think that participatory engagements in post-bio vacant land should not only be seeking some form of consensus on the future use of vacant land, but become an opportunity for healing social and ecological relations through restorative justice. In thinking through short, medium, and long-term, this is my last slide, in thinking through short, medium, and long-term visions for vacant land after retreat in historically disinvested communities, we should consider how ecological restoration work can be a form of relational reparation. I haven't fully sketched what this means, but fundamentally what is missing are practices that restore conditions for healthy trust relationships in Black and Brown communities. Such practices could include a politics of reconciliation through the acknowledgement of wrongdoing, and of power asymmetries, forms of deliberation that center the views, experiences, and expectations of communities, and land restoration projects such as landscaping, weeding, planting, where both the conceptual and material work is shared between restoration professionals and public volunteers. This work could begin where homely practices of Black and Brown placemaking are already happening, that are usually discounted, but which are crucial to hear from historical trauma and form kinship to withstand stressors. Accepting that there may be circumstances where practical restoration efforts are unwelcomed and unwanted, reinforcing the need for ad hoc ecological restoration neighborhood strategies. Coming to terms with historical injustices through restorative justice in disinvested neighborhoods is crucial if land restoration after retreat is to succeed in maintaining both community ecological health after piecemeal retreat. Some of my findings are published in this paper, and I'm working on a second one. Thank you.
Question? Across the other coast, on the role of nature in managed retreat in planning for resilient California coast by Piper Wallingford.
Hello, everyone. Good afternoon. Thank you so much for coming to my talk. My name is Piper Wallingford. I am the climate resilient scientist at the Nature Conservancy, California.
Sorry, sharing the Zoom again, my bad.
And today I'm going to be talking to you about the role of nature and managed retreat in planning for a resilient coastal California.
Like disappeared through the stick rule.
Technical difficulties, 1 moment, please.
All right, I don't know what's happening. Okay.
Okay, now we're back. So California is home to more species than any other state in the United States. And much of this diversity comes from our unique coastal habitats, which is home to many rare and endemic species. However, the coast is also extremely important for human communities, with the state's largest urban centers located along the coast, like LA, San Francisco, San Diego, and 68% of California's population actually lives within these coastal counties. And humans have lived and interacted with the coastline in California for thousands of years. And we can see this rich history reflected in our ecological and archaeological record. And there are many indigenous communities that have called California home. And this is just a reflection of all of the unique cultures that have existed there. In the past century, California has experienced an exponential increase in population, growing from less than 100,000 people at the end of the 1800s to more than 40 million people today. With much of this growth centered along the coast, natural habitats have been converted into built environment or have been heavily altered to fit a schema of what we think natural coast should look like. So I specifically want to point out this picture of 1930s Venice Beach, which is in my hometown of LA. And I mean, who wouldn't want to go there on vacation, right? So with the development of the coast, we've seen a loss of more than 90% of our historic wetlands and coastal dunes. In LA alone, more than 23,000 acres have been converted to a built environment. And if you've ever had the distinct pleasure of flying into LAX, you can imagine how different that community would look if we had our original coastal dunes and wetlands in the area. So not only are these areas super important in terms of providing critical habitat for species, but they also play a really important role in providing ecosystem services, like absorbing floodwaters and storm surge, ameliorating flood impacts, and sea level rise, and mitigating climate change through carbon sequestration. So restoring these coastal areas and implementing nature-based solutions will be critical for increasing resilience for both people and nature. But to do that, we need to understand which areas are at risk. So in 2018, TNC conducted the coastal assessment along with the State Coastal Conservancy, where we looked at the vulnerability of the California coast to sea level rise. We did this across 4 different ecoregions, so starting with the North Coast from Del Norte down to Sonoma County, the San Francisco Bay Area, the Central Coast from all the way down to Santa Barbara, and finally the South Coast, Ventura to San Diego. And within this assessment, we looked at the amounts and locations of vulnerable habitat, which are natural areas with projected impacts from 5 feet of sea level rise and limited ability to migrate inland. And we also looked at the vulnerability of the built environment. So the exposed built environment is any infrastructure that is projected to be impacted by 5 feet of sea level rise. And what we found is that with 5 feet of sea level rise, nearly 60% of our coastal habitats are vulnerable to losses, which amounts to around 90,000 acres. So that would be 90,000 acres of dunes, wetlands, and other habitats that could be lost. And we also saw that there were pretty significant impacts to people as well. So California's Ocean Protection Council estimates that more than 600,000 people will be at risk by 2100 from sea level rise. And at 5 feet of sea level rise, more than 100,000 acres of the built environment is expected to experience flooding. So we often think of these 2 impacts as separate, but we know that they're actually interconnected, right? So large areas of exposed built environment in close proximity to vulnerable habitat present potential opportunities to adapt the built environment and allow for the expansion and restoration of threatened coastal habitats, increasing coastal resilience. So to identify these opportunity areas, we need to better understand the spatial relationship between exposed built environment and the vulnerable habitat around it. So to build on the results of the coastal assessment, we conducted an additional analysis. And our specific questions were, how much vulnerable habitat is near exposed built environment? What are the specific types of exposed built environment near vulnerable habitat? And finally, where and how much of exposed built environment and vulnerable habitat are located in disadvantaged communities? So to understand this relationship, we conducted a proximity analysis. For each location with exposed built environment, we analyzed the amount of vulnerable habitat within 250, 500, and 1,000 meters. And we also identified the types of infrastructure that would be impacted, which we can break down into 4 different categories: residential and commercial development, transportation infrastructure, utility plants, which include things like wastewater treatment plants and power plants, and artificial shorelines. So for my talk today, I'm just going to be focusing on the results from our 250-meter analysis, because this is the area where nature-based solutions would have the largest impact. So we found that 47% of exposed built environment has vulnerable habitat within 250 meters. So that's almost half. And we saw that there were pretty strong ecoregional differences. So on this figure, we have on the x-axis our ecoregions going from north to south, with our area in acres on the y-axis. And we saw that almost all of that exposed built environment is located within the San Francisco Bay and South Coast area, which had around 17,000 and 6,000 acres respectively, compared to less than 1,000 for either the North Coast or Central Coast. And while both of these areas in general just have more coastal development, there are some pretty important ecoregional differences between the two as well. So the Bay Area actually contains 68% of the state's coastal habitat. So it's a really, really large area where, and has a really long history of coastal protection. So even though there's a lot of exposed built environment there, there's also a lot of habitat as well. Comparatively, the South Coast has been extensively developed, and the vulnerable habitat there often represents some of the last remaining habitat. So it will be incredibly critical to think about how we can prioritize protecting these areas. We also wanted to understand which types of built environment would be most vulnerable to sea level rise. So this figure again shows our 4 different ecoregions, starting at the north and continuing south in a clockwise fashion. Along the x-axis are our different kinds of built environment, with the area in acres on the y-axis. And just to note that the y-axis will be different for each of these 4 ecoregions. So across all ecoregions, we saw that residential and commercial development is the most vulnerable category. And if we break this down a little bit more, we can see that this largely consists of single-family homes. This was followed by transportation. Again, breaking this down, most of this was major roads, but we also saw impacts to railways as well as highways. And again, we see some really important ecoregional differences here, such as higher vulnerability for artificial shores in the Central Coast, or vulnerability for utility plants in the Bay Area. So understanding the local context and the impacts on the ground will be essential for identifying regional approaches. Finally, we looked at where these impacts would touch down in priority populations, which California defines as low-income communities that experience disproportionate environmental burdens and public health outcomes. So in this figure, our built environment, again, on the x-axis, with percent of exposed built environment within priority populations on the y. And across all of our ecoregions, more than half of exposed built environment of any category was found within a priority population area, with a large proportion of that having vulnerable nearby habitat as well. So prioritizing these areas for adaptation and implementation of nature-based solutions can help ameliorate sea level rise impacts in communities that have historically experienced these disproportionate burdens. While adapting built environment will be, adjacent to habitat will be critical for increasing resilience for both people and habitat, coastal migration space is also a complementary strategy that can help manage losses and create opportunities for nature-based solutions. So we can think of minimally developed areas like agricultural farms as potential future habitat. And this could allow for migration space of coastal habitats, which could reduce anticipated losses by up to 60% if these areas are allowed to transition to habitat. So this map on the right is showing a prime opportunity area around Moss Landing and Elkhorn Slough, which is California's second largest estuary, located in the Central Coast. And in this map, red areas are habitats that are vulnerable to sea level rise, and the orange areas are potential future habitat. So you can see that if we allow this transition to occur, it would not only increase the quantity and quality of the amount of habitat in this area, but also provide opportunities for increasing coastal resilience. And these strategies are really, again, complementary, and implementing them concurrently will have the highest benefit. And we can see this at Ormond Beach in Ventura County, where 5 feet of sea level rise would impact both the coastal habitat as well as the nearby community. Ormond Beach has a long history of environmental degradation, and today contains a wastewater treatment plant, a aging power plant, as well as a Superfund site, all of which are vulnerable to sea level rise. So TNC is working with state agencies, the city, and the local community to help rebuild some of this habitat and restore it to a functioning state, and create potential future habitat to allow that existing habitat to transition inwards, again, increasing resilience both for the habitats as well as for the nearby community. So to wrap things up, I just want to emphasize that climate change is threatening both ecological and human communities, but we can increase resilience through implementing nature-based solutions, which are a win-win for both people and nature. To do so, we need to better understand the spatial relationship between exposed built environment and vulnerable habitat in order to identify opportunities and priorities. Finally, we must consider equity when we're talking about climate change impacts and manage retreat. Marginalized communities often experience disproportionate impacts, and conversations around managed retreat have often not included them, as well as the recognition that for many communities, there is a history of forced relocation. So working with these communities will be essential for creating meaningful and lasting change. So with that, I want to thank my co-authors as well as our funding source, and I'm happy to take any questions.
Can you take into account vertical land motion in looking at sea level rise?
Yeah, that's great. So the question for the people online was, have we taken into account vertical land motion? This was just done with bathtub modeling, so really just looking at how much the sea level will rise. We are actually working with the University of California, Santa Cruz right now to develop a more detailed model that does take into account things like that, as well as subsidence and erosion. So it's to come. It's in the works. Yes, in the back.
Well, what's the agricultural response to these future habitats, like, because that's on agricultural land, and on just how much pushback do you get from that?
Yeah, it's actually been really interesting. So we have another project site in that Central Coast area that we talked about. And the growers there have seen loss of productivity as sea level rise is happening. There's been saltwater intrusion into these areas, and so they actually don't want to grow there. They're not making money off of it. So we've been working with our partners, the Land Trust of Santa Cruz County, to specifically buy out some of those areas and transition it back to coastal wetlands. And we've had a lot of positive impacts, but that's something that, took a really long time to create those relationships. So I think it is happening. It's happening slowly, but there is interest in this because it's no longer a viable growing area for a lot of them. All right, thank you. Oh, sorry.
Really quick, you should reach out to the people at NASA JPL. There are a lot of people doing really work if y'all need remote sensing people.
Awesome, thank you.
Okay, and so for the last talk, we're going back to the Indian Ocean, which is going to be me.
With this one.
I don't know.
Share this.
So estimating estimating subsidence, sedimentation, and elevation change in coastal Bangladesh using INSAR and surface measurements. So and it's being done along with a host of people, including ones in the audience here, looking at. So for those of you who don't know where Bangladesh is, it's in the northeast corner of India, and the Ganges Brahmaputra Delta, which incorporates most of Bangladesh, is the largest delta in the world. It's very low, very flat area. The coastal zone is about a 1 in a million slope. Okay, and so as a result, there's been lots of predictions about how Bangladesh is going to disappear over time from sea level rise, mostly done using a bathtub model because it's very low elevation. But in fact, it is a very dynamic place with 6% of the world's sediment passing through. And so really what you need to do is not just look at sea level rise, but also consider the fact that one, the land is sinking, is subsiding, but also there's a huge amount of sediment coming in. And so you need to take into account all of this in order to figure out what the future is. And so, as I said, there's a lot of sediment coming in, but the sediment is not evenly distributed. The sediment comes in on the rivers and gets deposited mostly around the rivers. These are some of my co-authors. And so what you see is in the areas around the river mouths is actually gaining land. So net, Bangladesh is actually still gaining land and is expected to continue to gain land as sea level rise because the increased monsoon will also bring down more sediment. However, what you see is that while it's growing new land near the river mouth, away from the river mouth is sinking and not getting the sediment. And so those areas in orange are not getting sufficient sediment. One of the responses that people have done is to build embankments. They use the Dutch term polder. There are 139 polders around here that they've gained, polders that have been built to try to protect the land and improve agriculture. They were mostly built in the 60s and 70s. And at first they succeeded in protecting the land. However, the land inside the polders is now no longer receiving sediments at all. As a result, it has sunk. And so when you take a look, what you can see is that pointer. Oh, that's a weird. Anyway, what you can see is that the land outside the embankment is higher than the land inside. As a result, there's been on the order of 1 meter to 1.5 meters of land loss on the inside of some of the embankments. I mean, the one we measured, which has caused a lot of switch from rice farming to shrimp farming. And in one of the polders that we've looked at, that we've studied extensively, called polder 32, was hit by Cyclone Isla in 2009, which breached the embankment in 4 places. And as a result, you can see the island was completely flooded. The initial repairs failed, and so the island was underwater for most of 2 years. So here you can see the island, also the island flooded. There's the embankment. What you can see is the land outside the embankment that's exposed to the river is at normal river level or normal land level next to the river, while the land inside, because it's meter to a meter and a half lower was flooded 10 hours a day, every high tide. And it looked like this with people concentrated living on the embankment for most of 2 years. And so, one question is, what do you need to try to protect this community if you have the land surface and sea level coming in? You could, one option, the one that Bangladesh has mostly done, is to build levees or embankments to try to protect the land. And the question is, how high a levee do you need in order to protect the land? You calculate some amount that varies across. This is based on Austin's estimates based on a cyclone that hit last year. But in the future, we have both more sediment raising the land as well as more sea level rise. And so, how much do you need? And one of the things we've concentrated on is, what's the right amount of subsidence that you need to include in these estimates, sort of the gross average, 10,000 year average sedimentation rate or subsidence rate is not going to be sufficient. And so I've been involved in whole lots of measurements that I don't have time to discuss very much, of different methods from both satellite and on the ground to try and estimate how much subsidence is going on. Here are just some pictures of some of the measurements using GPS, rod surface elevation tables, historic buildings, tube wells to drill the stratigraphy, and most recently using INSAR to try and estimate the land surface change. But when you compare all of those measurements are all measuring something slightly different. They're all rooted different ways. And when you take a look even in the same place, they're all giving different numbers. So you can see here that, different things like the rod surface elevation tables, the RSET, measures the shallow subsidence, whereas the GPS measures the deep subsidence. The ones on buildings miss the shallow subsidence. So they're all measuring different amounts of subsidence and sediment compaction over different depth intervals. And so Austin has developed a model using the stratigraphy that we've drilled and the sedimentation to calculate how much subsidence is happening with depth. And then you can integrate that according to each different type of measurement to get what the prediction of that instrument would be. And so here's one of the models where what you see is his comparison of observations versus the predictions for a central area centered around Polder 32, where we have the most measurements now. And you can see to first order, we're getting a pretty good estimate for a first pass. But what that means is that the different environments are also subsiding at different rates. So what we see is that buildings that, for instance, have a foundation and are rooted and are not getting any active sedimentation are not subsiding as fast. Areas like the open fields where there's sedimentation going on, that sedimentation is driving sediment compaction underneath it, and it's seeing higher subsidence rates, but it's actually keeping up because it's getting to sediment. So, there's a lot of difference of questions of what rate are you subsiding and whether or not you're keeping up with sea level as well. And I threw up the INSAR picture because you can see all the scattering in there, and then some of that is reflecting that there is a lot of local variability from place to place. But what that means is, what's going to happen for the future. See, if you take into account sea level height, you expect to see more inundation, you need to build that levee higher. But if you add in compaction, you see even more subsidence going on. And I've even shown a little bit of lack of elevation behind that levee going on. And some of that we can explain. Yeah, so we'll need more sediments. If we look at the contour map of the thickness of the sediments that we've mapped out, what we can see is that during the last ice age, the Ganges and Brahmaputra built big incised valleys that were later filled up with much thicker sediments than around it. And that's where we're seeing the larger amounts of subsidence, is where we have the thicker sediments to compact, thicker amount of younger sediments. And so the subsidence is very uneven. And, so we're beginning to map out where the expected elevation loss is, especially with the embankments, where we need to either, enlarge the levees or find a way to bring new sediment in to deposit and raise the land surface to compensate. There is enough sediment in the system, it's just not flowing in the right places. And, in terms, just wanted to end with the fact that we've also been involved in this project called CruiseNet, which is based out of MIT with private funding, trying to look at methods of adapting to climate change in Bangladesh. We're doing various modeling, including the subsidence, but also cyclone hazards and climatic hazards, and trying to come up with methods for both improved water security, adaptations of the agriculture and aquaculture, and flood and particularly heat shelters for changing climate. Okay. Thank you.
You mentioned just really briefly the agricultural land uses, switching from rice to shrimp.
Yes.
And did that increase subsidence?
I don't think it's increasing subsidence. It's more of, with the land sinking, some of the land inside the polders become waterlogged. That, since the land is lower than the river outside, the water doesn't drain. And in fact, one of the problems with switching to shrimp farming is what the shrimp need is salt water. And so it's also letting shrimp salt water in. And so there's some tension between the rice and shrimp in terms of needing freshwater land versus salt water for the shrimp.
There are any different techniques rather than just levees that are being used in Bangladesh, either to reduce sea level or mitigate sea level rise, or to increase sedimentation?
Yeah, I mean, there are actually plans to divert some of the sediment to create new land more in the farther east than here. The problems in the southwest is there's a mixture of natural changes in the river. The Ganges having moved to the east in the 1600s, and then increased usage of water in India and dams to divert water in India. That's also reducing the water coming in, and so the amount of water and sediment is less there. They've been trying to restore the Gorai River in this area for a long time and not been very successful about getting more sediment and water into the area. There's definitely a lot of issues to how to actually manage the area in the southwest where you don't have as much access to the natural sediment. All right, so yeah, I went through that talking very quickly. So we do actually have some time of the four of us who spoke to come up and continue the conversation with the group.
Hi, my name is Lilia. I'm a graduate student at UCSB, so University of California, Santa Barbara, and I work closely with Charles Lester at the Ocean and Coastal Policy Center, and we're working on an OPC grant to create a statewide beach resiliency plan for California. And so we've been thinking a lot about like adaptive capacity along our coast to, adapt and be restored into this critical habitat so that it can be maintained. And we've been thinking a lot about kind of new to me, which is like these different zones like along a beach, whether it's like a semi-vegetated zone or a completely dry zone or intertidal zone. And I'm curious if you thought about like within these critical habitats. I know you were mentioning it was also based on species, like if you thought about within a critical habitat zones that like segmented like that.
Yeah, so that's a really great question. And we're advisors on that project, I'm pretty sure. But one of the things that we've been thinking about at Ormond Beach, for example, is how do you restore the coastline to a fully functioning system? So all the way from those coastal dunes, the sandy areas, all the way to upland habitat. So specifically thinking more on like a landscape level of restoration. So you do have that wetland habitat, you have the lower marsh, the salt marsh, all the way up into your salt pans. And so that is something that's really important too. Is like when you're thinking about restoration, you can't just think about it at like a really localized scale. You have to think about it at the landscape scale. So that's a really great question.
All right, I have another question for you, and that is related. So when you're going about planning projects at the preliminary stages, the planning and site feasibility, um, I'm wondering what the process has looked like for you for going out and finding and outsourcing other experts like coastal engineers and those to look to make more informed decisions and actually go and do some data collection and just describe that process a little bit and even how specifically you would find the right group to work with if you go out and put out an RFP or
Yeah, exactly. RFPs. That's for those that don't know, that's a request for proposals. So oftentimes we work with contractors who specifically focus in on restoration. And so that's been really critical. We are a pretty large nonprofit organization, but don't necessarily focus on the restoration itself, specifically our team. We do have a land protection team, but they're focused more on like the long-term stewardship. They do restoration, but just to be honest, like everyone's pretty limited in capacity right now, especially with funding constraints. So being able to work with people who do have that expertise and who have worked on these projects in the past has been really critical. Yeah, we're doing this exact process right now. And so, I think one thing that's really important is making sure that whoever you're working with also has a vision for the site and understands the importance of working, as a thought partner and working with the local community to really make sure that you're getting that critical engagement.
Yeah, thanks very much for your talks. I mean, generally the discussion about nature-based solutions has become very popular lately. And my question, I mean, there are studies showing that wetlands can deal with relatively high rates of sea level rise, but when we're talking about coastal protection in near built environments, we know that nature-based solutions have their limitations. So I was wondering, in all those projects, do you have any information on the capacity of wetlands to deal with accelerated sea level rise? So we've done some global studies. We're dealing also a little bit in Germany with the issue, and we've seen that they can probably hold up for 6, 7, 8 millimeters. I mean, depending on of storminess, and we're at 5 already. So we're reaching the limits. And the question is there enough sediment? Is there enough space? Will we be able to use nature-based solutions for dealing with sea level rise? And I just wanted to hear your opinions generally, whether it's salt marshes, mangroves, coral reefs. So I was interested in your opinion about the topic.
Yeah, I mean, in Bangladesh, what we see is in the coastal zone where we have mangroves, is that the mangroves are keeping up with sea level rise. And when you include the subsidence as well as sea level rise, we're looking at probably over 20 millimeters a year of relative sea level rise. Whereas the built environment where you've tried to protect it is not keeping sea level rise.
Yeah, and I'll just add to that in California, we have so heavily developed our coastline that the reality is nature-based solutions alone are not going to be enough to keep up with the impacts that we're expecting to see. So there will need to be conversations around retreating from the coastline, around adapting built environments. And those are really tough conversations to have, but I think there's growing recognition that they need to happen.
Like New York City between 1890s till the 1950s lost 50% of its mangrove area in Jamaica Bay, where Edgemere is. So that's why in Edgemere, the conversation has been a mixture of retreating, mixture of U.S. Army Corps building sort of seawall protections, including living shorelines on the north portion of Jamaica Bay, and beach nourishment on the Atlantic side, including also building new housing. So I think New York City is pretty relentless in like we're not losing our tax base. So the retreating is very spotty, apart from Staten Island where we saw a lot of it.
One advantage Bangladesh has is huge delta. So the sediment comes out, and the mangroves are actually getting the sediment from the sea, sediment that comes out and then is washed back in to the coast from tides and storms, and not from the rivers, which are relatively limited in the western part. And so, it has the availability of sediments that, a lot of other places in California and New York City do not have. And in the Maldives, you're trying to grow it from the corals.
There is a lot of research about the coral reefs that they are able to keep up with sea level rise, and that's why I focus on the coral reefs. However, the rate of sea level rise is the issue. So if the rate is accelerating, then the corals will not. Probably it will be more difficult for them to keep up. However, there's been cases where you can see that the natural ecosystem, when it is fully natural without any anthropogenic impact around, then it is able to adapt.
We have one question online first, if that's okay. Question for Despina. How do you evaluate the efficiency of the recent building of artificial islands in the North Malay Atoll from the long-term and sustainability perception? Can MLD government continue with this adaptation strategy using the local corals for the building?
Actually, in the Maldives, they used to use coral stones in order to build. They stopped that a few years ago. It's not allowed anymore. However, an important thing that I want to emphasize is that it is easy for us to judge if we are not there. When you live in areas that there are no resources, you need to find ways to live. You need to find ways to build, so you need to use the resources that they already have there. Of course, they try to have a more sustainable coral farming, I would say, or there was a discussion, I don't know if it is implemented, but it's not allowed anymore to use coral stones as a building material. However, they use coral sand and coral remains in order to land reclaim islands. But these are found from particular locations after an environmental assessment report where they are allowed to take the sediments and build. For me, it's mostly the issue, the scale of the islands and the construction method of the islands that we are using, that instead of protecting the corals are being actually damaged, and the coral reefs are one of the most important assets in these areas, not only for the protection from the waves, but for sediment production, biodiversity increase, etc., etc.
Thank you. Who was the other person who had a question?
I just had a question for Veronica. I was curious if you could expand a bit more on. Oh, right.
Sorry, forgot that it's hybrid. I just have a question for Veronica on the last slide on your presentation. If you could expand a bit upon what you're thinking in terms of ecological restoration and relation and repair and kind of what that relational and reparative justice approach might look like, may perhaps scaled up beyond your study site, et cetera.
Yeah. So yeah, as probably you'll know, there's relational reparations and then there's financial reparations. So relational reparations have to do with rebuilding trust in communities that have been broken by promises that were not fulfilled. And so I think this approach, I think, should be taken in they're reflective of neighborhoods that have been disinvested over time. I think city agencies cannot go into a community proposing retreat if a sort of a texture of trust hasn't been rebuilt after decades of urban planning that didn't work for the community. So I was inspired by the work of Walker and Almasi on restorative justice. And in their terms, these can be projects that are done together with the public and restoration professionals and city agencies. So technically speaking, it should be a collective work where you undertake tangible work together. And in doing that work, you discuss issues of long-term neglect. So it's a deliberative process, which is very different from participation. So it requires a slowing down decision-making processes about retreat. Before proposing retreat, going back to what has not worked in this community and how can we make amends, admitting power relations. So it's a work that goes beyond retreat and it's before retreat at the same time. So this could be, as I mentioned, landscaping projects, gardening projects, planting projects that are done together with a community and sort of working out relationships that haven't worked for a long time. So it's actual working together.
We have another question from online for Mike. Yeah. Okay. Can we expect more sediment materials from Himalaya due to global warming effect and melting of the mountain glaciers? If yes, what will be their role in the protection of the coastal areas against sea level rise?
Yeah, actually, we published a paper on that about 2 years ago, estimating that as the monsoon is expected to get stronger, that we expect that more sediment will come up. So we calibrated using the past when the monsoon was stronger in the early Holocene to estimate an increase amount of sediment coming from a strengthening monsoon, and it basically, at least for the next 50 years, will allow Bangladesh to keep up with sea level rise.
I'm for Veronica. I'm wondering if you looked at successful community-based land use reclamation in places like Detroit, which has really done an incredible job of engaging and activating these spaces.
Yeah, I was actually in Detroit last year to do some work on vacant land, mostly from the point of view of title deeds and the history of title deeds, and where other community groups are doing work like urban gardens, but at a very large scale that are actually viable in terms of commercially viable. Yes, absolutely. I think so. Part of the literature review work that I've done was to look at other land restoration projects in the US mostly. And what I found out is that they may be mentioning the tools, the participatory tools they used, surveys or creek walks or picnics with the community to try to understand what kind of land uses they would want to have for lots, post-buyout lots. But there's not much of the discussion about the process, how they went about it, what was the outcome. And so that's the reason why I wanted to use a framework that sort of unpacks these the actual dialogue, what happened, who funded it, how much funding was available, and the type of trust and accountability relationships, and the history of the neighborhood and how that influences the kind of community organizations that show up at these kind of workshops, and their ability to mobilize renters versus homeowners. And I think there's not much of this research in land restoration when it comes to post buyout. Now, if it's just vacant land due to urban development, I think Detroit is a great example of this. And there, I think the outcome, sort of outcome that I got there is you have to be able to cluster lots to create larger size areas. Small vacant lots technically tend to be close to places that are inhabited by someone else, perhaps, who hasn't moved. And so in that case, I think the city needs to have a land bank available where they can sell the lot for like $100 to the person living next to it, and they will take care of it. I think the larger solution is to create larger lots from the onset. So before proposing retreat, these lots should be taken strategically in order to create these larger lots where you can create viable commercial farming, for instance, urban agriculture, that has happened a lot in Detroit. But yeah, again, this requires proactive retreat rather than reactive, which is what is happening here.
We have time for one or two more questions. We do have another one online.
Question for Veronica, just on sort of what you were sort of going at right now is that had, the original impetus for doing retreat in these places wasn't to buy out a floodplain place, but really thinking about strategically where sort of green spaces could provide sort of maximum benefit for, providing resilience as well as other community benefits. And I don't know this community that you were working in well, since I'm on the West Coast, but curious, a lot of what we think about on the West Coast is the sort of relationship between brownfields and opportunities. There's so little space for, particularly in communities that have poor park availability, open space availability, and whether there's, if that's something that you were looking at in terms of like models for actually achieving sort of the long-term benefits that you sort of thinking about.
I mean, there is a landfill in Edgemere that's owned by the sanitation department, and at the moment nobody can touch it, as in it's in the remediation process, and it's not even included as part of the buyout lots because it was empty to begin with. But what the community of Edgemere has expressed is the need for spaces that are not necessarily compatible with maintaining vacant land in perpetuity as open space. So a lot of the needs are commercial needs. They ask for multi-use facilities, things that could amount to building permanent buildings, which is not compatible with floodplain redevelopment. So the issue here is that you have a community that has that needs commercial spaces, needs more schools, and needs transportation, mobility. There's a lot of mobility issues from the north of the bay to the sea portion. So they want some transportation facility. They want small commercial opportunities like food trucks. But all of these things we were not capable to understand whether these developments are possible in floodplains, especially after buyouts. FEMA requires that the lot remain open in perpetuity. Does that mean that a food truck that doesn't have any permanent foundation is not allowed? That's something that wasn't clarified by HPD, the Housing Preservation Development. We know that some of the lots were acquisitions, so meaning that, and the city is actually pushing for redevelopment of new housing. The community land trust is going to happen on acquisition lots. But the larger issue is that there's no clarity in terms of what can be built and what cannot be built. The only clarity is around no permanent buildings. And so this was the kind of failure of this whole process, and that left the community sort of like, okay, so we can't use it, we cannot implement any interim use, and so what's next? Actually, the committee went on and had another visioning process. And so they're still ongoing on this, but I think there needs to be clarity on what can be built and what cannot be built.
Okay, sorry. Final question, super fast. For Mike, I conducted my fieldwork in Mongla, Bangladesh, and noticed significant dredging activity to enhance the passage of boats for port activity. And I could think this is also similar in Chittagong and other port areas in Bangladesh. Do you think this has implications for the sedimentation of inland within embankments?
Yeah, there's a lot of development going on around Mongla. Right now that there's a good road between Mongla and Dhaka. Yeah, so there has been a big question of dredge spoils from dredging lands, whether that sediment can then be used for, for rebuilding some of the land or raising homes in areas. And part of it depends on, for instance, I'd say when you do it, because some of that will be salt water, particularly in the winter season. The rivers are saltier, and in the summer they're fresher. And you don't want to be putting salty sediments in your to build up your land. So it's certainly a use that's been advocated by a number of people of reusing dredge spoils for raising the land, but it has to be done with thought to make sure you don't contaminate any of the land that you're using the dredge spoils on.
I was going to ask, isn't the sediment heavily polluted?
Certainly around Dhaka, it is. I'm not sure in the southwest whether or not it's heavily polluted. I've certainly swum in it, so I hope not. All right. And so with that, I want to thank everyone for coming and participating, and thank the speakers once again. So.